redox reactions, but this time a calculation. You see, redox reactions can actually be put to good use. You can use them to analyse all sorts of things, metals in coins, chlorine in bleach, you name it. Here's one. You can use redox chemistry to find the concentration of sulfite present in wine using acidified permanganate. Sulfite ions are added to wine as a preservative. They're added in tiny amounts, and it's possible to see how much sulfite is present by adding acidified permanganate. The more permanganate which reacts, the more sulfite must be present. If we wrote out a redox equation for this reaction, we find that every time 2 moles of permanganate react, there must be 5 moles of sulfite. We're given this on a plate. This is given to us. 2 to 5, or instead of 2 to 5, 1 to 2.5. So there we have it. Every time 1 mole of permanganate reacts, there are 2.5 moles of sulfite present. How would you actually do such an experiment? How would you carry it out? Well, you could, for example, put a sample of wine in a flask. You could put permanganate solution, which you made up, in a burette. I'm suggesting that permanganate has a concentration of 0.02 moles per litre. Now, it has to be acidified permanganate. You notice I've added the acid here, so that the moment the permanganate touches the wine, the permanganate becomes acidified permanganate. Without the acid, it won't work. We do the titration. Let's suppose when we do this titration, only 4 cubic centimetres of permanganate is actually added, just a very small volume. Can we use this to work out how much sulfite is present? Well, let's try it. We established a moment ago that the ratio of permanganate to sulfite was 1 to 2.5. As I say, you'd be given an equation which proved this. There we have it. 1 mole of permanganate reacts with 2.5 moles of sulfite. The question is, how much permanganate was actually added in this titration? Well, we know the volume, 4 cubic centimetres, and we know the concentration, 0.02. So if we know these two numbers, we can work out the actual quantity of permanganate using N equals CV. The concentration, we said, was 0.02 moles per litre, and the volume, 4. Be careful, of course, that's 4 out of 1,000. Volumes are expressed in litres. So how much permanganate is that? Very small quantity. This is very dilute and a very small volume. So when you do this sum, it comes to 8 times 10 to the negative 5 of a mole. Tiny little amount. But if we apply this 1 to 2.5 ratio, there must be 2.5 times more sulfite than permanganate. So if we've got that amount of permanganate, multiplying by 2.5 gives us 2 times 10 to the negative 4 of a mole of sulfite. So the question now is, what's the concentration? You see, this is N, this is number of moles. We want to know C, the concentration. There's one other thing we know, and that is V, the volume. The volume the sulfate is in. The sulfate sitting in 100 cubic centimetres of wine. So the volume is 100, to be more accurate, 100 out of 1,000, because as we said, volumes are always expressed in litres. So we want to know the concentration. You'll remember this relationship from standard grade, NCV. The number of moles we've established from the experiment is 2 times 10 to the negative 4. The volume we know is 0.1. The concentration we want to know. If we do this sum, we can see concentration is moles over volume, N over V. That's 2 times 10 to the negative 4 divided by 0.1 comes to 0.002 moles per litre of sulfite. In other words, there's just a trace of sulfite, an incredibly dilute solution of sulfite present in the wine, just enough to preserve it.